Hey guys, today we are going to continue talking about arc length and sector area of a circle, and specifically we are going to do this in a measurement called radians instead of degrees. So what you're seeing right now is a unit circle. Okay, so this unit circle has some degrees on it, 30, 45, 60, 90, and so on, all the way around to 360. And it also has corresponding radian values. So radians is just another way to measure slices of a circle. So right here, we have a 30-degree angle. Okay, so when I go 30 degrees around this circle, I can also call that pi over 6 radians. And when I get to 90 degrees, I can also call that pi over 2 radians. 180 degrees is pi radians. And then when I go all the way around the circle, I'm at 360 degrees, which is also 2 pi radians. So we're going to find arc lengths and sector areas in radians. So we'll do some arc lengths in this video, and then in a separate video, we will do some sector areas. Okay, so here we are with some arc lengths to find, and this measure right here is a radian measure of this arc instead of a degree measure. Okay, so it's important to remember that 360 degrees is the same as 2 pi radians. Okay, so when we find the length of an arc, we're going to use this formula, the length of the arc, so I'll say the length of, and then we'll call it arc AB, is to the circumference of the circle, which is pi times diameter, as the measure of the arc, and I'll put an R here for radians, is to 2 pi. Okay, now previously when we did this, we put in the number of degrees over 360, but in radians, it's the radian measure over 2 pi. Okay, so here for number 1, we have a radian measure of 5 pi over 3. We have a radius of 9. So the length of the arc, and I'll just call it L, is to pi times diameter, and the diameter would be 18. As the radian measure, 5 pi over 3, is to the radian measure around an entire circle, which is 2 pi. Okay? Now, my variable is on top, which means I can just take this denominator here and multiply it diagonally across. Okay, so that gives me the length equals, and then 5 times 18 is 90. So we've got 90, and then pi times pi is pi squared over 3, all over 2 pi. Okay, so I did 18 times 5 and pi times pi. So I've got 90 pi squared over 3 all over 2 pi. Now 90 is divisible by 3, so I'm going to divide that by 3 and I get 30. Okay, so what I have is the length is 30 pi squared over 2 pi. Okay, now I can cancel some pi's. So pi and one of these pi's cancel. So I've got 30 pi over 2, and that is going to simplify. 30 over 2 is 15. So 15 pi meters is the length of the arc. Okay, so number 2, I have a measure of 2 pi over 3 radians, and I have a radius of 13. So the arc length is to the area of the circle, pi times, and then the diameter. I'm sorry, I said area, I meant circumference. The diameter is 26, pi times 26. Okay, so the length of the arc is to the circumference, as the measure of the arc, 2 pi over 3 radians, is to the radians of an entire circle, which is 2 pi. So I can take this and multiply it diagonally. Okay, so I get the length equals 26 times 2 is 52. Pi times pi is pi squared over 3, all over 2 pi. Now in this case, 3 does not go into 52, so I'm not going to be able to simplify 52 over 3. Okay? But what I can do is put this right here over 1, and this is my favorite way to divide fractions. If I multiply this outer loop here, I get the numerator. So I get 52 pi squared times 1, and then the denominator is this inner loop here, 3 times 2 pi, and that is 6 pi. Okay, now I can cancel out a pi from the numerator and denominator, and I can simplify the fraction. 52 over 6 simplifies to 26 over 3, so the length here is 26 pi over 3, and this is in feet. Number 3, I'm in degrees now. Okay, so I'm going to say the length is 2 pi times diameter, pi times 12, as the number of degrees, 135, is to 360. When I'm in degrees, I'm putting it over 360. When I'm in radians, I'm putting it over 2 pi. So I'll multiply this across. So the length is 35 times 12. And I'll just make this into a fraction. I'm going to do 35 times 12 in the numerator. And it's over 360. And that is 7/6. Okay, now, see my mistake here? I put 12. That's not right. I have to have the diameter. That's 24. Okay, so clear that out. So I've got 24 times 135 in the numerator and 360 in the denominator, and that comes out to 9. Okay, so I have 9 pi kilometers as my arc length. And here's another one in degrees. Okay, so my arc length is 2 pi times diameter, pi times 6, as my degrees, 195, is to 360. Okay, again, degrees, 360, radians, 2 pi. So I'll multiply this across, and I do 195 times 6 in the numerator, and in the denominator, 360. And I get 13 over 4. So I have 13 pi over 4, and that is in yards. Okay, now I'm going to skip all the way down to the bottom. We'll come back to those other ones. Those are area. We'll come back to those in another video. Okay, find the length of arc ABC. Okay, so that's this arc out here, this major arc. And I know that this right here is pi over 3, but I don't know what this is. Now, if it was in degrees, I would just do 360 minus these degrees. But it's not in degrees, it's in radians. Okay? Remember, all the way around a circle is 2 pi. So I'm going to do 2 pi minus pi over 3. So really what I'm doing is 2 minus 1/3. And I can do that in a calculator. 2 minus 1/3. And that is 5/3. Okay, now I didn't put the pi in there, but that means that my radian measure is 5 pi over 3. So there's my radian measure. So the arc length is to the circumference of the circle, pi times 14, as the radian measure, 5 pi over 3, is to 2 pi. We'll just ignore that right there because that was a mark that I made when I wasn't really thinking about what I was doing. Okay, so I will multiply this across. So I've got 14 times 5, and that is 70. Okay, so I've got the length is 70 pi times pi, so 70 pi squared over 3, all over 2 pi. Okay, now 70 over 3 does not simplify, so I'm going to put this 2 pi over 1, and I'm going to multiply an outer loop to get a numerator. 70 pi squared times 1 is 70 pi squared. Okay, and then 2 pi times 3, that inner loop is 6 pi. I can cancel out a pi from numerator and denominator, and I can simplify 70 over 6, and get 35 over 3. So the length of this arc is 35 pi over 3, and that is in meters.